There's one more important concept that we have to understand in working with C#, and that is understanding type conversion. And if you've come from a language like C or C++ or Java, you've seen this before. Converting one type of variable to another is called casting. And this is the kind of thing that pops up in languages that require you to give types to your variables. You're probably wondering, or at least you soon would be, well, how do I share data between variables that are different types? And the way that you do this is by casting one type of variable to another. It's how you convert data types among different kinds of data type variables. So for example, suppose I had an integer named I, and it's set to the value of 10. And I also had a float, and that was set to the value of 20.0. Suppose I wanted to set f to the value of I. I could just do f equals I, and that's okay because that's an implicit cast or conversion from an int to a float. Since an int is 4 bytes and a float is larger, there's no risk of data loss here. The integer can simply be converted into a float and all is well. The reverse is not true. If I said I is equal to f, that causes an error because you need to explicitly cast from the float to the int because data might be lost. You can't fit all the precision of a float into an integer automatically. However, if I did this, if I said I is equal to, and then in parentheses I put the word int in front of the variable that I'm casting from, that's now okay. I've explicitly cast or converted from the floating point value to the integer value. And you'll see this all over languages like C and C++ and Objective-C and Java and now in C#. So let's go over to the code and actually see it in action. So here I am, I've got my conversion project open, and I'm going to open up my snippets file. That's right there. So let's go ahead and scroll down to the conversion section. And that's right here, type conversion. So I'm going to copy those lines, and I'm going to paste them in here. A couple of things. You can see that I've got an integer, a short, and a float. So in this case, the integer starts out as 10, and the short starts out as 5. Now you'll notice that I can simply assign the value of x to the value of I. Why? Because x is a short. It's 16 bits, whereas the int is 32 bits. So there's no loss of data here. That's okay. The compiler doesn't complain. However, if I try to go the other way, if I try to set the value of I into x, well, there's data loss here, or there's potential data loss here. What's going to happen is I've got 32 bits trying to go into a 16-bit bucket, and you can see that the little squiggle is saying, hey, error, cannot implicitly convert type into short. Are you missing a cast? Well, yes, I am. All I need to do is say, if I put the word short in front of the I variable inside parentheses, that says to the compiler, hey, compiler, take the value of I and explicitly convert it into a short. And now you notice that the little red squiggle has gone away and everything is just fine. So let's go ahead and put a console.writeLine in here. And we'll write the value of x, and we'll write out x. So let's put a console.readLine at the bottom. And let's also comment out that error for the moment. So let's save it and run it. And you can see that the value of x is 5. Why? Because here we put x into I, and then we just put I back into x. And since x started out as 5, that's what's happened. So now x is back to being 5. So let's suppose we comment this line out, and we make I something that a short can't handle. So something like 800,000. So now when we run this, you'll see that the value of x is 13,568. Why? Because some of the bits of the integer got stripped off. Remember, the integer is 32 bits, but the short is 16 bits. So 16 bits of information got stripped off, and what was left over was what could fit in those 16 bits, and that worked out to be 13,568. So that's the kind of thing you need to watch out for when you're working with type conversion, because some types of containers are larger than others. Let's go back to the code here. Let's go ahead and get rid of these two lines. And let's look at the floating point versions instead. So here you can see I have the floating point number f, which is equal to 20. And here I've got the I, which is now 800,000. Again, I can assign the value of I into the value of f. Why? Because floats are larger than integers. That works just fine. Same story down here. I'd have to actually cast the float to be an integer. And in order for that to work, I simply put the word int inside parentheses, and now that converts the value of the float into an integer, which can be stored inside the integer variable. You'll see this kind of thing all over C# code, and you see it in other languages as well. It's important to understand how conversion and casting works because you'll be using it in your own code.